Hi everyone again. We're back to the Italian C++ Conference 2021. This is the second part of the conference, and we have our speakers Mattia and Eric. Hi Mattia and Eric, how are you doing today?
Hi, fine. Everything okay? You, Eric?
Fine, thanks.
Great. We are ready to attend your talk about AI, so looking forward to it. And so I leave you the stage. I remind to the people that Eric and Mattia will take questions at the end. So use the Q&A tab on Remo and enjoy the session.
Yeah. So good afternoon. And thanks to the Italian C++ community for having us today presenting our project Ai4Prod that myself, my name is Mattia Verasani, myself, Eric, my colleague Eric Tondelli, and also Samuel Pietri, we are developing all together. So maybe we can start also with the sharing of my slides. And basically, today we are going to present to you this project, Ai4Prod, and this is going to be the outline of the presentation. So we are going to start with a brief introduction about the main challenges that we have witnessed during our years in developing deep learning and machine learning projects in a production environment. So we're going to do this brief introduction about which are the main challenges, what we have faced, and so on. And then we're going to give to you an understanding of why, then from these challenges, we decided to develop Ai4Prod and create this kind of ecosystem. And then Eric is going to do a deep dive inside the code, inside the ecosystem that we developed with the practical examples of what we have done so far. And to be clear, we would like also immediately to underline our goal, why we have developed it and why we have thought about this ecosystem and we are trying to build this kind of ecosystem. And the main idea is to provide a tool that speed up and simplify your usage of artificial intelligence in a C++ production environment starting from tomorrow. So this is our idea and our goal with this ecosystem called Ai4Prod. So we would like to speed up, simplify the usage of AI, artificial intelligence, C++ in this production environment, and start it actually from tomorrow. So you can download it, and eventually you can immediately start, dive deep into it, and eventually do really fast a project based on deep learning or machine learning techniques. So as I said at the beginning, why we have done this. And first of all, we need to understand actually what is happening when you try to develop a deep learning machine learning project and you want to put it in production. So you want it to act in the real world. So this is a picture that I think if you are in the field, you have seen plenty of times, and in particular, we have taken from the TFX workshop this time, and is underlying this critical aspect. So if a client or whatever is going to give you a bunch of data, when you do deep learning or machine learning, you create a model that needs to fit on top of this data. So the model needs to fit the data in order to have great predictions, in order to have this model making prediction about the task that you need to predict. By fitting the data, by fitting your training data set that the client is going to give to you. And actually, if you go around GitHub and so on, you can find already tons of open source models. You can download Python script, you can download notebooks, exploit this algorithm, try to fit on your data set, and eventually you came up with prediction and so on. But the real challenge then is how I'm going to have it working in the real world. What is happening when from my laptop, where I have fit the data and so on, I want to have it in multiple devices across the world, and I want it to do real-time prediction and real usage about that. So as you can see, there are tons of things that need to be built, and you need a really strong infrastructure to have machine learning, deep learning models working in the real world. And as you can see here is underlining some of them, the gray boxes that you are seeing there. So for example, you need data collection, feature extraction methodologies, a monitoring system, analysis tools in order to check also what is happening if the model is drifting or not. So you need tons of stuff to control your machine learning and deep learning model that you have deployed in a production environment. So it's really challenges, and you need a really strong infrastructure. Among all these building blocks that you need to have deep learning and machine learning in production, during the years, me, Henrik, and Samuel, we have seen tons of challenges in this particular aspect. So every time we have trained our model in Python and so on, then most of the time you want to focus on a C++ production environment, because in automotive, automation, gaming, and so on, tons of the products are built in C++, and the production environment is mainly built through C++. And integrate what we have trained in Python inside the C++ production environment for us has been quite challenging. We've seen a lot of challenges. For example, here we have listed some of them. So sometimes was quite difficult to find an exact C++ equivalent library with respect to Python. Nowadays, maybe you can see LibTorch, but at the beginning, what was quite challenging to find something like this. And also, really important, verify that what you are developing and deploying C++ and the model embedded in the C++ production environment has the same accuracy respect to the one to what you have built in Python. More important, cross-platform also deployment. So you want to have your system being able to operate on different operating systems and also on different hardware architectures. And also, sometimes you can think to retrain your model on the device itself. So you don't want to collect the data coming back to your workstation, retrain and redeploy. Maybe you want to do a retraining on the device itself. And you need to understand also how to retrain in a C++ production environment. So we have seen all of these challenges, and we have witnessed tons of them. And we were in this kind of situation every time. So we have lost tons of time. There was no standard way to do stuff. So every time you need to come up with a solution from scratch for different type of algorithms, for different types of tasks that you need to solve and so on. And so it's going to bring a lot of headache, tons of bugs everywhere, and so on. So we say that what about having something that is going to try to solve all these issues? So it's going to try to give us the possibility to have a tool that actually is helping us on deploy on different hardware, architecture, and operating system, exploit heavily then C++ for inference, so C++ production environment for inference. More important, have also a standard pipeline for training my algorithm, and then from the training stage then to the inference stage, I have a standard pipeline that I needed to fulfill, and I don't have to reinvent the wheel every time that I need to create a new task or that I'm involved in a new task and so on. And also, can also have a tool that is easy to customize. So if I have different needs and whatever, can this tool be able also to easily be customized for my needs, for the needs that I have in my deep learning machine learning projects? So we thought about that, and we say, okay, it's time to do something. And we came up with this idea of Ai4Prod. So we have created this kind of ecosystem, and our goal, as I said at the beginning, we really want to try to simplify the creation of whatever artificial intelligence powered products you're going to build in C++, and having the standard pipeline that I told you before, and so on. And what are the kind building blocks and more relevant things that you're going to find in Ai4Prod? So what we try to build, it has in mind this kind of thing. So we want something that is really easy to integrate in your projects, that is really easy to customize, and that is able to working on different operating systems and hardware architecture, I will say at the beginning, and that gives us the possibility to have a standard workflow to follow. So this is the follow. We need to take several steps, and every time is going to be the same for whatever task that we need to solve, and also give us the possibility to speed up our project development and deliver really fast what we have built. So here we are going to show you what actually is Ai4Prod. So imagine that now you have a deep learning project or machine learning project, and you need to hit the market as soon as possible with this project. So imagine you are in this situation, you want to build a deep learning or machine learning powered application, and you want to hit the market as soon as possible or deliver to the client as soon as possible. So by exploiting Ai4Prod, you are going to find a standard way to handle any project that you will face in your working situation and so on with this ecosystem that we have built. So with this ecosystem, you're going to find a standard way to handle any project that you need to create, that you need to deliver, and so on. And in particular, in this ecosystem, you're going to find different pipelines, okay, composed by different steps that you can every time take in a standard way for whatever project you're going to face. And in particular, which are these steps? So here are shown the steps that I'm talking about. So step one is going to be the training of your model in Python. So what does it mean? Eventually, I'm going to have a training set. I'm going to build a machine learning or a deep learning model that is going to be able to fit on this training set in order to give me a really good prediction. For example, I want to predict cat and dog and classify whether an image is in an image of a cat or an image of a dog. I'm going to have a training set based on cat and dog, and I'm going to create a model that is going to fit on this data in order to predict actually when an image is from a cat or from a dog. And after that I trained it, what I want to do is I want this that from my laptop is going to hit the real world. So whatever image is coming in of my model, so in the inference stage, whatever image is coming in my model is going to predict with high accuracy it is a cat or it is a dog and so on. But how can I pass to the training to the inference stage? I'm going to take step 2 first. So I'm training my model, step 1 in Python. I want to pass to the inference stage. So step 2, I'm going to convert my model for the C++ inference engine. And then step 3, I want to hit the real world. So what is going to happen? I'm going to exploit my converted model inside my C++ inference stage. So this is the whole pipeline, and these are the steps that you can follow with our ecosystem. And in particular, as I said before, we're going to have different pipelines. What does it mean? It means that, for example, think about you could face different type of tasks. You can face different type of downstream tasks for your project. So you want to do a classification task. So you're going to find a classification pipeline. Find, for example, if this image is it has a cat or a dog. And object detection pipeline, thinking about self-autonomous driving car, you want to detect what is inside the street, traffic lights, stop signs, and so on. You're going to find an object detection pipeline here. You're going to find also an instance segmentation pipeline and time series pipeline, for example, to analyze time series that are coming in. So you're going to have also this time series pipeline. So you're going to find different kind of pipelines composed by the 3 steps that I told you before: train, conversion, inference in C++ then. And on top of it, you can also find extra modules. What does it mean? So for example, the pipeline are in the way that I've described it before. And for example, you have the classification pipeline. The classification pipeline is going to be the training, conversion, inference on a task of classifying, for example, cat, dogs, whatever. And on top of that, you can add an extra model on top of the pipeline, for example, to monitor the performance of the models, if there are drifts and so on. In particular, all these extra can be applied or on some of the pipelines or on all of the pipelines. For example, the model performance monitoring, you can apply on all the pipelines, time series, instance segmentation, and so on, because detecting the drift of the models is relevant for all the pipelines. Whereas if you think about the tracking module, tracking, for example, you want to track some cars, some stuff, and so on inside your videos. Tracking you cannot track through a classification methodology. You cannot track time series, for example. Tracking is really suitable when you have an object detection pipeline or an instance segmentation pipeline. So if you want to add on your object detection task tracking capabilities, you can take this extra module and build and put it on top the pipeline that you already find inside Ai4Prod. So as I said, you can find in Ai4Prod all this pipeline already built in, and then also extra models that you can put on top of the pipeline that are already present. And actually, you can also integrate extra code, extra stuff on top of the pipeline in order to have extra capabilities and extra modules. Before giving the word to my colleague Eric, I would like just to give you an overview of our repository that you can find on Git. Everything is open source. And the repository is divided in two main repos. Sorry for the repetition. One is the Ai4Prod Python, in which you're going to find step 1 and step 2. So step 1, training your models, and then step 2, convert your models. So you're going to find all the library in Python to train and convert your custom model. And the other repository, Ai4Prod, is the main one. And it is the library in C++ that is going to exploit the models that you have trained and is going to do inference in C++. And is going to fulfill step 3. So that's it from my side. I will give the word to my colleague Eric now, that is going to show you a practical example of our project.
Okay, thank you, Mattia, for this great introduction of Ai4Prod. Now I will share my screen in order to get started with some tutorial and how you can find documentation and so on. So let me know if you can see my screen. Mattia? Okay, perfect. So starting from what was the last final slide of Mattia, here you can see that we are on GitHub and we are the two repositories that Mattia mentioned. The first one is the Ai4Prod Python that you need to use for do the step 1 and step 2 of our pipeline, and in particular train the model and convert it. And the second one is the main C++ project that once you have a converted model, you have to build this library, and after you can do inference in C++. On the README, you just to mention two important links. Here you will find all the dependency that this repository needs. Inside this link, you can find dependencies for all 3 operating systems, so Windows, Linux, also embedded system. And the other important link is that here is the models. We have already convert a lot of model for you, just to give you a sort of quick start with this repository. So we have also build a website, and this is really useful because in this link you can find the documentation, and so you have always a reference on how to build Ai4Prod, especially in the repository in C++ for different operating system. And also you have the tutorial. Just to have a quick overview of the tutorial, because as you can see, as Mattia said, in each tutorial you can find the complete pipeline. So the pipeline is divided, also the tutorial is divided in these 3 main parts. This part 1 is always how to train your model with custom dataset. The second one is how to convert your model on ONNX format. That is the format of the model that you need to use in order to use the model in C++. And in the part 3, you have how to deploy effectively the model on different operating systems. So, okay, this is the more general overview of what you can find on our repository, and if you need help with the documentation and so on. So, starting from the real part of this coding tutorial, I will go through the how to build the Ai4Prod for Windows. Of course, how you also build for Linux, and it's quite similar because under the hood, we are using CMake as our build system. So if you are not familiar with CMake, it's a cross-platform compiler for C++. Also here, 2 notes. So Ai4Prod could be developed on different hardware. So if you're using GPU, please check that you need to install the CUDA toolkit. Right now on Windows, we are supporting 11.0 version of CUDA. And of course, if you have not a GPU, don't worry about this. You can just start and download. But if you are going to use Ai4Prod in a GPU environment, you need to install this one. In the future, we will also provide library for the library for other version of CUDA. Right now, you have to use with CUDA 11.0. So around the tutorial, as I said, we use CMake to install the library. So if you just on Windows, is quite easy, just download and install the executable. And you have 2 options to build the library. The first one is you can use directly our build script. So the build script, what is doing is downloading all the dependency of Ai4Prod, and it will set up all the folder hierarchy that you need to have. And the last part right now is how you can use CMake. You need to use this command in order to build the Ai4Prod. So a quick overview of the option that you need to use. CMake install prefix is where the library will be installed. Execution provider is a provider that Ai4Prod is built on. For example, if you are referencing TensorRT, is referencing NVIDIA library for optimizing inference in GPU. So with TensorRT, you are using GPU under the hood, and TensorRT is only a way to optimize the inference on GPU. And for example, if you want to use CPU, just write here instead of TensorRT CPU, and Ai4Prod will not looking for GPU dependencies. Here is a typical. I'm using Visual Studio. I want to create a Visual Studio 2019 project. So from here, we can go briefly around the building process. So the idea, once you have downloaded the repository git clone, it's easy to do. You can create a build folder, and inside the terminal, if you execute this command, you will get this output substantially. And in this output, you will see that CMake automatically generate a Visual Studio 2019 solution. Inside this, if you open, you can see different projects. And so the most important one is this one that you need to compile in release mode if you want. And catch test is just about testing if everything is working in Ai4Prod. We use this for debug purpose. And once you have built the Ai4 production, you need to install the project. So when you compile the project, so you build the install project, what's happening is that Ai4Prod automatically create the installation of the library. So remember that Ai4Prod is a library. So in these steps, we are not creating an executable, but we create a DLL file. So right now, if you see, for example, I have make a test command example. I have installed this in post detection install. So inside example folder, post detection install inside install folder, here is the installation of Ai4Prod. So starting from this point, you can integrate this library in every kind of C++ project. For the example, right now we are show to you a pose estimation example. So to integrate Ai4Prod, you need a CMake file. I will not go through this project, this file, sorry, because if you're not familiar, it's not so clear, but just have a look, and it's quite straightforward to integrate our project in your library or in your custom executable. So as before, if you want to execute the example project, just open a new terminal. As before, create the build folder, and with the same CMake command as before, you can create a new Visual Studio project. This one is the one that will create the executable. So I'm already open it. This is the inference project. Inference project, there is one main file. And first of all, I want to show you, before starting the tutorial, I want to show you what is the output. So human pose estimation is a task that is composed by two different models. The first one is you need to do object detection, and the second one is use a model to estimate the joint position of the human. So what these two models are doing is, the first one, the object detection model, is finding a bounding box around the person, for example, in this example. And the second one is that, given that bounding box, is estimating the joint position of the person. Right now, this is the output of the model. And so starting from this, this is the output. I want to show you what is an overview of what we will find inside the code. So, as Mattias said, we try to standardize as much as possible how you can deploy each pipeline. So, for example, each pipeline is composed of three methods: pre-processing, run model, and post-processing. For example, if you also have object detection pipeline, you will find always these three methods. And if you are doing instance segmentation, you will find always these three methods. Okay, having this big overview, we will go through the code. And so at the beginning, you only need to include...
Can you increase the font size of the code?
Yes. It's okay.
Maybe another one. I think now it's okay. Yes.
Okay, perfect. Thanks. And so at the beginning, you have just to include some header. This is quite standard. We are using namespace Ai4Prod, object detection, and post detection. Right now, we need also to include OpenCV because we are using this library to load the image or images if you want. And so starting from the real part of Ai4Prod, so every pipeline, every model is a class. So you can instantiate the class, and we instantiate YOLO before, that is object detection model, and HRNet, that is the human pose estimation model. And so as we can see, first of all, you need to init the model. So right now you have always to check if this return true, because it means that the model is correctly initialized. And so from here, the first parameter is always the model that, for example, you have trained in Python and converted in this ONNX format. So as you can see, HRNet model and YOLO v4 model, always you need to provide this ONNX model as the first parameter. The second and the third parameter are the input images, the size of the input images that the models expect. Because, for example, in the real world, you have, of course, different kind of image size, but the model always needs to be always the same size. So you need to specify this at init of the method. Otherwise, you will get an exception, because the model cannot process sizes that is not where is not trained on. And the other parameters are the class in which you have trained your model. For example, on object detection task, 80 is 80 different class, because, for example, in object detection, in the images, you can recognize human, but also cars, truck, and so on. And so you have to specify how many classes your model is trained on. For example, if you are doing a custom trained, maybe this value is changing, because maybe you have not 80 class, but maybe you have only 2. And so here you can customize just changing this value.
Eric, sorry, I can't,
yes?
if I interrupt you. Could you increase more the font size again? Okay, nice. Thank you.
Okay, good. So here is the other parameters. This TensorRT or CPU is really important, because you can decide where the model is, which hardware the model is using. So, for example, right now, HRNet, that is the human pose estimation, is using CPU, and instead YOLO v4 model uses TensorRT. Of course, you can change, and there's no problem on this. On Windows, you have another option that is using DirectML, that is a sort of library provided directly by Windows, and it's better than CPU, but we have made some tests, and it's worse than TensorRT on inference time. So if you have GPU, I suggest you to use always TensorRT. And the last part of every model is where we are saving the configuration file. So configuration file, if you're coming from production environment, I personally use it a lot, because it lets me to save the state of the system. So, for example, if you are in production and you are making some test on a new feature, etc., and maybe you need to reset the last state of the model, having a configuration file is really, really useful. So we use this to save the state of every model. So you can always go back to your previous state of the model if something is not working. So starting from once you have initialized each model, as you can see, here is the main processing of the YOLO v4 model. As I mentioned before, the YOLO v4 has these 3 methods that are preprocessing, run model, and post-processing. These 3 methods, the name at least, are the same as HRNet model. So once you understand how to run YOLO v4, you can also run HRNet without any pain. And this is what we are doing, is trying to standardize as much as possible as we can. So a little explanation of what we are doing here. In the pre-processing stage, Usually now we are looking at object detection, so we are working with images. So at the first stage in the preprocessing, we are feeding the image this preprocessing, and what's happened inside here is that the images is converted to a tensor, because most of the time the model in C++, the library that we are using under the hood, is expected a tensor to process. And so here is in the pre-processing, we are resize the images at the right dimension, that is here. And so after that, we are converting the images to a tensor. So this is what is happening under the hood. But as you can see, is just calling a method. In the run model, and this is always the same for each model, is running your inference process. So in this is where the actual inference process of the model is happening. So in this run model, you will insert the input of the tensor as input, and you will get another tensor as output. And the last step is to do post-processing. Why you need post-processing? Because, for example, in object detection model, there is a problem with the output of the neural network. Because, for example, imagine that you have an image with 3 persons. So for each person, the bounding box is not only one at the output of the model. So in a short way, using an algorithm that is called non-max suppression, I will not go into the details if you want to check it. The idea of non-max suppression is that for each person, you have for example, 3 bounding box, and using non-max suppression, you will get only the best one. So if you have 3 persons, after non-max suppression, you will get only one bounding box for each person. And this is a really important step. Otherwise, you cannot really use object detection model. So from the result of the post-processing, you will get a bounding box. Right now, think about the image as I showed you before. We have only one person, so the result tensor is have only one bounding box. This is for cycle if you have multiple bounding box. Right now, this is execute only one time. So here you have inside the result tensor, you have x and y coordinate and width 8. We use a standard OpenCV structure to create a rectangle that is our bounding box. And now we start the processing of the second model. So again, as you can see, the name is the same. YOLO v4, HRNet, doesn't matter which model you are doing, you have always the same type of method. The only difference maybe is the parameter that you are inserted in this preprocessing stage, because right now, as you remember, HRNet model is expecting not a full image, but only the bounding box with inside there. You need to have a person in this kind of model. So in the preprocessing stage, you pass the full image and the bounding box that you will get from the YOLO before processing. So as before, HRNet run model is doing the inference stage, and so is as before running you will use an input tensor and you will get an output tensor. As before, you are doing also the post processing. In this case, if the name of the function is the same as before, inside here we are doing another things. For example, in the HRNet model, there is no the same things that you need to do as in YOLO before post-processing. So And also the result of this step is different. So right now, when you are here, what you got is another tensor. As before, we tried to standardize. So YOLO v4 output of the full inference process is a tensor. Output of the HRNet model is always a tensor. The things that is changing is how the data are stored inside this tensor. So, for example, here, ignore this one because, again, this first for cycle is if you have multiple bounding box inside the same images. Let's start simple, consider only this one. So inside the pose result tensor, what you got is 17 elements with X and Y coordinates that are the joints of the person. So at the end, we draw the circle in the images. And after we visualize using the CV imshow. So starting from this, I launch the code just to have a quick demo. So right now, what's happening is loading the model, and so after all the steps that we have covered, you get the results. So you can try this tutorial, make some changes, change the images, put more than one person in the images, and you will get this evaluation of the human pose. Last thing to mention that is really useful in some cases, on object detection, we add an option. So in this vector is you can select the classes that you want to retrieve. So right now I put only 0 because in the model classes 0 correspond to humans. If you want to do, for example, human pose on animal, sorry, you have to change this class, and everything in the code remains in the same. So this is more or less the overall process of this human pose estimation example. As you can see, if you have a look in other tutorials, you will find always the same pattern. So pre-processing, run model, post-processing. Doesn't matter if you are doing classification, as said, or instance segmentation, always the same steps. What is changing maybe is the input size of the model, and maybe, of course, the model that you need to use, because right now we know that YOLO v4 is an object detection. Of course, you cannot use HRNet on YOLO v4 class, but I think it's quite obvious. So last thing that I want to briefly explain, because in production environment, for me, is really important, is that configuration file. So as you can see, in the model, HRNet is executed on CPU, while YOLO v4 model is executed with TensorRT on GPU. So the real difference between CPU and GPU is in computation time. On TensorRT, you will go much faster. And at the end, we will see the results, because we have already checked the results. But the important thing is this configuration file. So once you have created
Eric,
yes.
If you can increase the size also
yes.
of the notepad. Yes. Nice.
Okay. So as you can see, this is used to restore the state of the model. So for example, on YOLO v4, this is the parameter that I told you before. If you increase this, you will get less false positive, but also less detection, for example. And you also here, we save the path where the model, the path that the model that you use to perform this example. And so all these parameters are useful for restore the state of the system. So one important thing to remember is that once you have created this configuration file, the second run, Ai4Prod, if the configuration file is present, is loading these parameters. So for example, if I change this one right now, in the end, it takes no effect because Ai4Prod always load this if it's present. So if you want to change and I don't know, the idea is not to change this parameter because it's a reference for your production. But if you are aware of this, you can do also different tests. The important things here is this FP16 parameter. So this is useful only if you are targeting GPU. So for example, and in particular, if you're using TensorRT. On the other modality, for example, on CPU, it's not so important. But on TensorRT, this makes the model much faster. If FP16 means floating point 16, and usually the model is in floating point 32. Okay, so this is more or less the whole overview of the project. I want to finish to mention, as Mattia said at the beginning of this presentation, the people behind the Ai4Prod. I am me, Mattia, and Samuel. And Samuel right now is working on how to integrate Ai4Prod on creative coding world. So, for example, with I don't know if we don't know what is creative coding, but it's quite interesting field of C++ also. For example, Unity is a good software to starting on, and Samuel is working on integrate artificial intelligence in this world. Have a quick recap. So, what we'll present in the end is Ai4Prod. So it's a tool to help you to do inference in C++. With the Ai4Prod, you can speed up your development using already tested pipeline. Pipeline is the full process of training, converting, and do inference in C++. Ai4Prod is built to work independently on different operating systems. So what we saw here on Windows, you can replicate with no pain on Linux and also Jetson embedded. I have to mention that if you are targeting an embedded device, it's not a good idea to run on CPU because it's really slow. And as we can see, you can deploy model on different hardware. So as before, we have deployed a model on CPU and GPU using TensorRT. It's production ready, and of course, open source. To finish, next steps. What we will integrate in the near future. First, we want to integrate also on iOS and Android because we think that it's good to have also these platforms in our portfolio. And so add new models, for example, semantic segmentation that is similar to instance segmentation, but it's a different area of machine learning. Adding an extra such as model monitoring that right now is in developing status, but it's not open source yet. And as I mentioned, integrate Ai4Prod on creative coding and gaming, and also a lot of other things. And so I think that for this presentation is all. And if you have a question or please ask. We can try to ask.
Thanks, guys, for the great talk. And yeah, I think we have some questions in the Q&A. So we start from this one that I can yeah, that I can put into the banner here. When a model is converted to C++, does it generate C++ code that gets compiled and optimized, or a graph representation that's loaded and used by the Ai4Prod library? That's the first question. Is well, I think it's about ONNX. So it's if I understand correctly, it's well, it's not. Yeah.
I'm taking, or are you taking it, Eric?
Go, Mattia.
Okay. So if we get correctly, we're not actually generate code when we convert it. So basically, as Marco was saying, is a ONNX conversion. So basically, let's give a quick, fast example. You are training your model on MXNet or PyTorch, which is a Python framework that are usually exploited, or other frameworks, and so on. We are exploiting ONNX, which is called Open Neural Network Exchange, which is giving you the possibility to convert from whatever framework you exploit to a general kind of methodology, which is the ONNX one, the ONNX format. So basically, we are loading the graph representation. So in particular, what is happening is that if you are exploiting PyTorch, for example, we are moving from a dynamic graphs to a static graph, which is the ONNX one. And then inside the C++ code that we have already built, you are going to inject this model on it. So basically, we are loading the static graph representation of the model inside the C++ inference engine.
Great. Yeah, and indeed, some people in the chat are. Yeah, I was saying that ONNX is basically the answer. Okay, next one is by Matteo. Is asking if does the framework handle models generated by both TensorFlow and PyTorch? And this is basically, again, I think the answer ONNX, but I leave it to you.
Yeah, so I take it, Eric, again, or as you wish.
I reply just to let you know that I attended the talk, so just because this is why I have replied. But no, sorry, I don't want to reply.
No, but it is already what you said. Basically, it's ONNX the answer. Yeah. So I don't know. You want to go, Eric, or as you wish?
Yeah. Yes, it's similar to the previous answer, but the answer is ONNX. So you have to think that you can use a different kind of machine learning framework as PyTorch, TensorFlow, and ONNX is just a tool to convert the model in a standard format. So it doesn't matter if you're using TensorFlow, PyTorch. The output of ONNX is always on NX frameworks. The things that you need to be sure is that if you are using or PyTorch or TensorFlow, you need to check if the model will be generated correctly, because sometimes this is not always the case. So while we developing, for example, our Python part, we also add code to check this. So, but if you have your model, for example, in TensorFlow, you can run, directly on Ai4Prod without any problems.
I can just add a thing. So I'm just adding that with TensorFlow is not as straightforward as for PyTorch. So PyTorch has an heavy integration with ONNX Runtime. TensorFlow, it's a bit more difficult. There are open tools that are giving you the possibility to convert from TF format to the ONNX format. But I have read 2 weeks or 3 weeks ago, I don't remember, that now TF Lite, whatever you are doing with TF Lite, can be converted in ONNX format, if I remember correctly and if I read correctly. So maybe double check it for the TensorFlow format. And we are going to double check it also from our side, of course.
That's great. So the next one is from Roland. He's giving a talk about AI in a couple of hours. So he's another speaker that probably we can all catch up all together at some point. Is a hot topic for you, Mattia. I think it's some applications you need to run online learning. How do you handle that?
Yeah. So yeah, online learning, or it depends on if you are in a continual learning setup. So yeah. So for now, it is in our roadmap. So we have not yet started that part, to be honest. So as we said, we have not open source what we have done, and we are studying how to make it run it in a standard way and try to embrace it. So that's it.
Cool.
So
Nice.
the quick answer is no, we are not handling it yet, but it is in our roadmap.
Okay, last one, and then I think we can also move to the networking if we don't have any other questions. Are most refactorings common between? No, sorry, this is this is from the last talk, and this is this one actually. I didn't paste it correctly, so now it's pasted. Okay. Yeah. So did you consider having preprocessing return the tensor as a return value instead of returning void and storing the tensor with the model? I think this is kind of a style question about the style of the library itself.
I will answer. Yes, if you go around, I think version 0.4 of Ai4Prod is what is basically we do it. So instead of handle all the tensor processing inside directly the class, we return the tensor in the preprocessing step. But we changed this idea because, for example, one idea is that if you, for example, want to run preprocessing and post-processing, for example, on thread-safe environment, for example, all the classes we handle this thread-safe. So, for example, you cannot run preprocessing you cannot run model without having run preprocessing. So let the user to return this value and then pass it to, for example, to run model. I think it's at the end it's quite confusing also in the code. In this way, you have always this standard workflow. And the other things is that it's true that you always need, for example, in preprocessing, you always use a tensor to handle this. But in reality, for example, on different kind of model, this tensor could be very different kind of dimension. So maybe it's not a good way to let the user to access directly this during the pipeline, because we want to only access the tensor when the full process is complete. So in the post-processing steps.
Great. Well, I think we don't have other questions or comments. So thanks a lot, guys. And you mentioned you're available for some follow-ups in the networking area. So you'll find a table with the follow-up for track A. So for all the other people, if you have other questions or you want to do some comments to Mattia and Eric, please go to the networking right now with them, and then we'll get back to track A in 15 minutes to attend Sandor's talk about the const qualifier. So thanks a lot again, Eric and Mattia. See you around, hopefully. Thanks a lot for your great session.
Thanks for having us.
Cheers, everyone. Let's meet in 15 minutes in track A, or see you around in the networking. Cheers.
See you.
Bye. Thanks.